Hello. So in Unit 5, we're going to look at some more coding, C# coding in Unity. And so we're going to do that by looking at an inventory system created by InScopeStudios. There's a longer video introduction to this, but we're going to just walk you through in about 10 or 15 minutes the basics of it. So our main idea is that we have a player and it will object or script, and it will talk and work with an inventory script. The inventory script will have a list of game objects that'll hold these slots, and each slot will hold one or more items. Eventually, in the more advanced tutorials, will create a stack of items in each slot. But the initial code will just have one item in each slot. There's also an inventory manager that's going to set this up and work with this. So let's just look at how this might work. So I'm going to run this. So we have a simple player here, and there are some simple objects, collectibles we can pick up. We can hit B to display an inventory, and then when we pick up items, they're all displayed in the inventory. We should be able to click on them, right click on them to use them, and it should say something like used health potion here that we want. There's also an option to drop them, but that's not fully implemented in this version of this system. And then you hit B again or I, and that goes away. The inventory system goes away. So basic system here. So if we look at the setup here of the objects in our scene, we have our player object, and that has a player script attached to it. The player script has a public variable called inventory, and we drag an inventory object onto this. So there isn't an inventory object here. It's actually built into the player this way. We also have a set of collectibles that are out there, things we can collect. And so we have these collectibles. They're prefabs, and each one has a item script which has information about that item, and also some sprites that are used to display that item. And when you drag these onto the screen, you can fill in under your level, you can fill in information and make each one somewhat unique by changing their characteristics here. And these are there's prefabs for these. We just have a couple samples here. There's also a rotator script that simply rotates it. This is very similar to what's in the first rollerball tutorial that we looked at. There's an event system and a canvas that's used for our user interface that's displayed that. Again, that's whenever we add a UI element here, it creates a canvas and an event system to handle that sort of information for us. So things like our inventory is actually displayed here, and our tooltips and our stack size is also here. I mean the display information is used where we're displaying the tooltips or the stack information, and some of the instructions text is here. There's an inventory manager object which includes links to some of the information out there that we can collect, and some of the links to some of the text that we have. This is supposed to kind of manage the GUI or the front end visual aspects of our code. But it doesn't do a great job. I mean, well, we'll see it in just a sec. So if we look at the code in Visual Studio, we have the player script here. And it has a link, a public inventory that links to the inventory. And again, when we drag and drop that in here, we drag this inventory that we've created into the player object here. That links these two together. So we have this inventory here. It has inventory script attached here. And so those are tied together. When we do this, we also want the inventory system to be able to get back and look at the player. And so when the inventory system is created, it finds the player and stuff. So we have these general information here. And then when the inventory is started up, it finds the player. Here down in the start area, it finds the player and keeps track of a reference back to the player. So inventory can access the player, and the player can access the inventory, which is often helpful in some of our coding things. So then there's movement. I'm not going to go over the player movement. It's really primitive. We also have two triggers here. One is for a trigger, and one's for a collision. We both check if the item is tagged item here, and then we add the item to our inventory, calling the add item method in the inventory class, and passing the object we've collided with or that we've run into with the trigger here. And now notice when we collide with it, we destroy it, and when we do a trigger, we just set it to inactive. This actually does not work very well with destroying it, because what we want to actually do is keep the item around so that it can be just added to inventory. We don't want to destroy it. So we actually just use this trigger event in our code. And so our objects out here that we can run into, they are all should be set up, their box sliders to trigger. So the trigger event will happen. If I select one of these objects, so if I were to select one of these objects and make it so it wasn't trigger, it would use the collision event. And then I'll notice that although I can collide with it, it doesn't add it to the inventory. So if I bring up my inventory, generally when I collide with the object, it puts it in the inventory. But here, now I collide with it. Oops, it drew it in there, but it's not actually there, and it's overwritten later on because of that. And the reason is we don't want to destroy these objects. We want to just put them in inventory and hide them, and then later on when we drop them or use them, they're still around. So we don't use this this collision. This is just some old code that I left in there to show you what it is. So we want to make sure our game objects, we are running off of the trigger event. Okay. Now let's look at the inventory. The main thing of its inventory is, again, our array list, or our list of game objects. We have a list of game objects, and we are storing slots. So we have little slots or boxes that each box in our inventory is called a slot, and we can store one item or more items depending on how we have this coded in these slots. There. So there are kind of some helpful, an is open method here and empty slots. Now, these might look a little different than if you're used to Java. These are properties that are called in here. So rather than just having a global variable with a getter and a setter, these are properties with a get and set built into them. So they're using C# properties here for these global variables and getter and setters. And again, we've got our reference to our player object. Another thing we should mention is that we only want one instance of the inventory here. So we check, we use what is called the singleton pattern here. We check, we keep track of the reference to the inventory item up here. Here's our inventory item, an instance of that. We check when we first start if that instance is null, and if it is, we'll find the inventory item and keep that here. Otherwise, we'll just return the link to it. So we are always just working with one inventory item. So even if there might be two or more inventory items for some reason on in the scene, we'll always just be working with an instance of one. So this is an example. It's an example of kind of the singleton pattern here. Really, we shouldn't be instantiating another one, but the way Unity is set up, these are already instantiated, and so we're just always returning the same link to the same instance of the inventory item. There's an update item that handles the mouse up and down. So this is the mouse clicks on the screen for us. And this can let us do things like drop an item and things. Some of that stuff isn't, or hover over an inventory item, it'll display some of that sort of stuff. I'm not going to go too much into that sort of ideas here. And there's also tooltips. When we go over an inventory item, it'll show information about that item when we go. And create layout lays out the whole inventory system and how it's displayed. This is where I think there is not a really clear distinction between the GUI version, the user interface portion of inventory, and the other ones. I would have preferred all the references to the canvas and that sort of stuff, the size of inventory bay in like the inventory manager here. And here, or at least some clear separation. So it doesn't use a very good, what we'd call a model view controller. Certainly the view stuff is set up with this, the canvas and areas like this, but we mix the data for the inventory with the controller for that. So I would have liked to have seen this separated a little bit better, but that's okay. So that's the basic inventory stuff. There's an add item that places the item, checks if it's empty, and adds it to a slot. It will look for an empty slot. So every slot out there has a slot component. So we'll just mention, so inside our inventory display, there'll be lots of slots, and each slot will have a code for it. So there's a slot script inside each slot. So similar, there's a player script inside each player and an inventory script inside each inventory. But scripts want to generally talk to themselves, to another script, and call methods in another script, not just access the other object. So we'll see a lot of this. So we'll get the slot, but we'll also get the component, and this slot with the capital S refers to the script, the slot script on the slot object. So once we have this reference, and we're saving this in a temp and its type is slot, which is this object, this class. Then we can check like the is empty flag within that slot, so that'll look at this is empty here. It'll also, we can say temp add item, which will call this add item method down here. So again, this is how we often, if even though we have an object, we want to get the code, the script that's associated with that object, and work directly with that from one code to the other. So inventory has this slot, these slots that are here. Each slot in our inventory can hold one or more items. Right now, each item has an item slot, but again, later on in the code, they actually stack the items, and so we'll see they'll create a stack of items in each slot. So multiple items will be in each slot. So if you have 5 health potions, they can all be stacked in the same slot if you want. And again, we have properties here that are set up, and the normal, some stuff with the sprites here. Using an item, we will call find the slot item and call use. So we will store an item in each one of these slots. So again, when we run into an item, we'll call add item, and then we don't store the entire game object here. We just get the item script. So when we run into an item, so let's say we're running into this sword, we won't store this whole game object. We'll just store this item script in our inventory. And so we're that. So then when we're using an item, we can just grab that and say use, and that will go to the item area and call use directly there. Some other things about removing items and using items and the pointer click. Now, most of the other two classes are just to implement mono behavior or inherit from mono behavior here. Slot also is handling some mouse clicks because it's a user interface stuff, so it's implementing a class. I'm not a class, an interface, and that's why I see the I here, interface for mouse pointer click. So it is implementing, we don't use that many interfaces in Unity, but this is one we do. Instead, we tend to use these, what are called component-based programming. So let's look each item out there. So like health potion will have an item script attached to it. So will a mana potion, and so will a sword potion, where in other places you would see maybe an item interface, and you'd have maybe a sword or a thing collectible class that would implement this item interface, and we'd have like an add item and use item method in that. We don't use that here. Again, we tend to use these component-based systems more in Unity, and so the item script is added. The same type of item script is added to all 3 of these. So we'll see a little bit difference when we get to the item script here. There's some enumerated types we'll use up here, and then we use, again, we're just inheriting from mono behavior. And like, here's a general use method, but again, because we're using the same script on lots of different things, we're checking the item type, and depending on the item type, we're going to use it differently. We're not actually usually, and then later on the examples actually increment the health. This would actually increment the health or stuff like that. But here we're just putting a log that says we would increment the health here. We can display tooltips and information like this for this. And again, there's not a great distinction between the GUI interface and the item here, unfortunately. Okay, the last thing is the inventory manager, and this does just manage the what we're displaying as far as on the items and the slots, and what types of game objects can be stored in inventory, and what they will be used for that. So there's an inventory manager that's working with some basic slot management and stuff here. And this becomes more critical later on when we work with stacked and other sort of inventory items. Okay, so that's our basic characteristics. We have a player. Player is linked to an inventory. Inventory has a list of slots. Slots can store one or later on more items in each slot. We have these items here. When the player collides with something, we take their item script and store that in a slot. We don't try to destroy that item. We just make it inactive here, and then we have an inventory manager that kind of controls the whole thing. So that's our basic system here. Hope you enjoyed this. Again, you can watch the tutorial from InScope for a lot more details on how this is all coded.